A very warm welcome. We are Team Business Brainiacs from Rajlakshmi School of Business. We are going to do the project on student innovation under Clean and Green Technology SIH 1487 on the title Domestic Waste Segregation and Solar Powered Fertilizer Production. As our world embraces a greener and more sustainable future, innovative technologies are transforming even the most common objects, such as waste bins. The amount of domestic waste in rural areas is rising steadily, and its composition becomes increasingly complicated over time, thereby exerting a great pressure upon rural environment. For villages that are far from cities or towns, sources of domestic waste are segregated due to the relatively dispersed rural population. This means that centralized collection and transportation of garbage is costly and inconvenient in these areas. Moving on to objectives to promote a healthier ecosystem by minimizing plastic waste, to enhance plant growth and vitality through the natural release of nutrients, to streamline fertilizer with biodegradable bins. In pursuit of more sustainable agriculture practices and waste management, the transformation of biodegradable waste into organic fertilizer stands out as a promising solution. By integrating solar panels and IR sensors into this process for biodegradable and non biodegradable segregation of daily waste at our place itself. Modern chemical fertilizers include one or more of three elements like nitrogen, phosphorus, potassium, whereas the fertilizer from waste will be chemical free. Moving on to process flow, firstly, the domestic waste will be segregated as non biodegradable and biodegradable waste. If any non biodegradable waste is found, an alarm will alert the user via an app that is developed. Biodegradable waste will be transformed into fertilizer by solar powered bin. Glass sheet cover on the lids of biodegradable bins and concave mirrors are used to reflect sunlight into a single focal point, which warms the bin to transform biodegradable into fertilizer. This warming of bin occurs by converting solar energy into heat energy. Speaking about benefits, safety assurance, minimizing risk of chemical exposure and accidents, environmental protection through prevention of fertilizer runoff and contamination, reduced risk of contamination for ensuring proper nutrient delivery to plants. Solar power source offers several advantages, which is reduced carbon footprint. By utilizing renewable energy, these bins reduce reliance on non-renewable power sources. And then cost saving. Solar powered bins can significantly reduce operational cost, making them a cost effective and eco friendly choice. Self sufficiency. Solar panels allow these bins to operate autonomously, reducing the need for frequent maintenance and external power sources. And then RGB sensor is used. RGB sensors are integrated into bins to accurately identify and sort waste materials. These sensors provide a range of benefits. Waste categorization. RGB sensors can differentiate between various types of waste, making it possible to sort recyclables from non recyclables. And increased recycling rates. With precise sorting, these bins encourage recycling, which reduces landfill waste and promote a circular economy. Real-time data. The sensors provide data on waste composition, helping municipalities and waste management services make informed decisions. And IR sensors are used in the bin. Infrared sensors are used to detect contaminants such as non biodegradable materials within the biodegradable waste. Their advantages include contaminant removal. IR sensors can identify and segregate plastics, metals, or other non biodegradable items, ensuring that the waste stream remains clean. Environmental protection. Removing contaminants from biodegradable waste prevent pollution and helps preserve the environment. Enhanced recycling. Separating contaminants at the source ensures that recyclable materials remain uncontaminated and can be effectively recycled. In conclusion, the combination of solar power, RGB sensors, and IR sensors in biodegradable bins represent a remarkable leap in environmental sustainability and waste management. These smart, eco friendly bins harness the power of the sun, use intelligent sensors to sort and detect waste, and promote recycling, all while reducing the carbon footprint associated with waste disposal. This innovation not only benefits the environment by reducing waste, preventing contamination, and conserving energy, but also offers economic advantages through cost savings and efficient waste management practices. As our world increasingly focuses on sustainability and responsible resource usage, these biodegradable bins serve as a shining example of how technology can be harnessed for the greater good, helping us move towards a cleaner, greener, and more environmentally friendly future.